Welcome to Brain Vision.
Okay, what we want to do is step through the process of being able to determine the molecular formula for a substance called equilin. We are starting with 13.42 grams of equilin, which contains only carbon, oxygen, and hydrogen, and when combusted produces 39.61 grams of CO2 gas and 9.01 grams of water vapor. And we're told that the molar mass of equilin is 268.34 grams per mole. Okay, so what we first need to do is we need to actually find the mass of, so kind of like the first step is to find the mass of carbon and hydrogen given the masses of CO2 and H2O. So we're going to find the molar mass. So we're going to find the molar mass of carbon dioxide and the molar mass of H2O. Okay, so depending on what periodic table you have, we have one carbon, so that is 12.01, and we have 2 times oxygen, which is 16.00. Okay, we're going to add those together, and we should get 44.01 grams per mole of CO2. Okay, so that's the molar mass. And now we're going to do the same thing for H2O. So we have 2 hydrogens, so we do 2 times 1.01. Now, some of your periodic tables might have this as 1.008. Depending on your periodic table, go with the periodic table you have. Sometimes oxygen is 15.999 if it goes down to 3 decimal places. And then, of course, we have 16 here. And we add those together, and we get 18.02 grams per mole for the molar mass of H2O. Okay, now if we want to do the mass of carbon, so in CO2 we have 1 mole of carbon and 1 mole of CO2. So what we have is we are starting with 39.6 grams of CO2. We're going to change to moles, so we have 1 mole of CO2 for 44.01 grams of CO2. We have 1 mole of carbon for 1 mole of CO2. And we know that carbon is 12.01 grams of carbon for 1 mole of carbon. Okay, so let's see if our units cancel out. So grams of CO2, mole of CO2, mole of carbon, and we're left with grams of carbon. So that's how we find the mass of carbon. And so the mass of carbon is 10.81 grams of carbon. And we're going to do the exact same thing for hydrogen. Okay, so we're going to find the mass of hydrogen. And so in water, we have 2 moles of hydrogen for 1 mole of, so we're looking at the coefficient and the subscript. So 1 mole of H2O contains 2 moles of hydrogen. So for the mass of hydrogen, we're starting with 9.01 grams of H2O. And we're going to kind of do the exact same thing we just did with carbon, okay? And so we know there's 1 mole of H2O to 18.02 grams of H2O. We have 2 moles of hydrogen for 1 mole of H2O. And we have 1.01 grams of hydrogen for 1 mole of hydrogen. Okay, and so we should get 1.01 grams of hydrogen. Okay, so that's the mass. Okay, and then we could do a couple things to find the mass of oxygen. So we know that for the mass of equilin is 13.42 grams. Well, that total mass of equilin should be the masses of each of hydrogen, carbon, and oxygen added together. So that might be the easiest way to do this. So the mass of carbon plus the mass of hydrogen plus the mass of oxygen should equal the mass of equilin. Okay, so I basically have the mass of oxygen equal to, we were told this was 13.42 grams of equilin minus the mass of carbon, which is 10.81 minus 1.01 grams of hydrogen. And that should give us what is left over for oxygen in that total amount. And so we get 1.60 grams of oxygen. Okay, so we had to get all the masses of carbon, hydrogen, and oxygen. So now we need to find the percentages of each of those. So, so now we need what is called the mass percents, which is going to be equal to the mass of each element divided by the mass of the compound. Okay, so what we have here is the percent of carbon is going to be equal, the mass of the element was 10.81, and the total mass was 13.42. And of course, this is going to be multiplied by 100 to get the percent. So this is 80.55%. Okay, and we're going to keep doing it. We're going to do the percent of hydrogen, the percent of oxygen as well. So now we have the percent of hydrogen is the 1.01 divided by the 13.42. And then, of course, times the 100%. And 7.53%. And then the percent oxygen, we're going to do the exact same thing, is 1.60 divided by the 13.42 times 100%. It's 11.92%. Okay, so now what we need to do is to divide the percentages by their average atomic mass. And this will give us kind of some moles. So what we're going to do is we're going to take, for carbon, we're going to take the 80.55. And the reason why we're doing it is we're assuming, we're going to just assume everything's out of 100 grams. So that means that percentage, 80.55%, could mean that it's 80.55 grams out of 100 grams, right? So that's kind of what we're doing. And so then we're going to divide by the 12.01 grams per mole. So this is grams per mole, which then gives us the 6.71 moles. And we're going to do the same thing for hydrogen and for oxygen as well. So we're going to keep doing that. And so this would be 7.53 grams divided by the 1.01 grams per mole, which gives us 7.46. And we're going to do it for oxygen. Okay. And that was 16, wasn't it? Okay, and now what we're going to do is we are going to divide each of these moles by the smallest. So oxygen is the smallest, right? So we're going to take each of those and divide by the smallest. So we're going to take, and that, so for carbon, we have 6.71 divided by 0.745. And that is equal to 9.01. And then, of course, we are going to round to the nearest whole number. Okay, and then hydrogen is equal to, we have the 7.46, and this is 10.01, whoops, which is 10. And then, of course, when you do oxygen, of course, you're going to get 1, right? So you're going to have 1 here. Okay, so this is telling me now that the empirical formula, not the molecular formula, but the empirical formula is C9H10O. Is equal to C9H10 and oxygen. Okay, so that's the empirical formula. We don't want the empirical formula, we want the molecular formula. So the molecular formula is the empirical formula times the subscripts times something, okay, some n value. And so we need to find what that multiplier to the subscripts is. So the multiplier, whoops, to your subscripts is found by actually taking the molecular weight and divide by the empirical weight. Okay, so, okay, and we're told back up here the molecular or the molar mass of equilin was 268.34 grams per mole. So that is the molecular rate. And the empirical rate is going to be 9, because we have 9 carbons, so 9 times 12.01, 10 times 1.01, and 16. And we're going to add those together. And that is 134.19 grams per mole. I don't know why it's kind of like on a delay, which is frustrating. Okay, so that multiplier is going to be equal to that molar mass that we were given, which is 268.34 divided by the 134.19, which is equal to 2. So now what I'm going to do, the molecular formula now is I multiply all of my subscripts by 2. So the molecular formula is equal to C18H20 and O2. And there we have it. So it's not a hard process, it's just a lengthy process.